Heritability in the broad sense. Defined as the proportion of phenotypic variance that is attributable to the overall genetic variance for the genotype. Why important heritability in the broad sense? It is plugged into the breeder's equation to predict the response to selection. How to use the Broad-sense heritability equation. Recall the Broad-sense heritability takes into account multiple types of genetic variance, not just additive genetic variance. Broad-sense heritability is mathematically expressed as h to the power of 2 equals Vg Vp. In this equation, h to the power of 2 is Broad-sense heritability, Vg is total genetic variance, Vp is total phenotypic variance. Total genetic variance is a collection of the three kinds of genetic variance previously described, so total genetic variance can further be expressed as Vg equals Va plus Vd plus Vi. In this equation, Vg is total genetic variance, Va is additive genetic variance, Vd is dominant or recessive variance, Vi is epistatic variance. The typic variance of quantitative traits is the sum of their genetic and environmental variance. Both of these variance components can be entrained by controlling for the environment of growth or for the genetic composition of the population. If we know what part of the phenotypic variation is actual genetic variation, then we can calculate the Broad-sense heritability, which is simply the amount of genetic variation relative to the total phenotypic variation in the population. Broad-sense heritability is a parameter that varies between 0 and 1. If its value is close to 0, then the studied trait has no heritability, and all phenotypic variation you observe is due to environmental variance. On contrary, if broad-sense heritability is approaching 1, then almost all of the phenotypic variance we observe in the population is due to genetic differences between the individuals. A very important thing to remember about heritability is that this is a parameter that is measured for a population. A broad-sense heritability for carrot weight to 0.7 does not mean that if we look at one individual carrot, 70% of its weight will be determined by its genes and 30% by the environmental of growth. Heritability simply cannot tell us that. What heritability tells us is that if we look at the entire population of carrot in the field, among all the phenotypic difference we observe between individuals, about 70% of them will be due to genetic variation between individual carrot. So heritability is not very helpful if we're interested in the precise genetic determinism of a trait or its inheritance, but it can help us make some predictions on the population level. And this is precisely the information plant breeders need. Heritability of a trait of 70% means that most of the phenotypic variations in the population is heritable, and it means selection is applied. It will result in a permanent change of the trait under artificial selection. On the other hand, if heritability is low, it means that most of the variation observed in the population is due to microenvironmental differences between the individuals. In this case, applying mass selection to improve the trait value will have a little to no effect, or instead a more efficient way to modify the trait is to grow the plant in appropriate environmental conditions.